Every night, we spend hours lying horizontal and completely still, physically paralyzed, accepting a hallucinated reality as absolute truth. For over a century, the dominant view followed Sigmund Freud, who argued that dreams were a disguised attempt at wish fulfillment, a way for the subconscious to signal desires we ignore while we're awake. But when researchers combed through hundreds of thousands of dream reports from around the globe, that personalized view begins to dissolve. The data reveals that human beings everywhere are running the same plots. Whether you are an American college student today, or living in 1950s Japan, or an indigenous society deep in the Amazon, the internal scripts match. Across all languages and eras, people consistently dream of falling, of being violently chased, or failing a simple task. There are also strange, universal omissions. Despite the time we spend staring at smartphones or reading, cell phones and books almost never make an appearance in our sleep. Because these shared narratives ignore our daily habits and span the entirety of human culture, they suggest that dreaming is a fixed property of the biological engine found in us all. The shift begins with a mechanical lockdown. As you enter rapid eye movement, or REM sleep, a neural circuit in the brainstem triggers atonia. Your major muscle groups are paralyzed, preventing you from physically acting out whatever your brain is about to experience. This model illustrates how the brain then alters its routing. The executive network, located heavily in the frontal lobes, handles rule-based logic and analytical tasks. During REM sleep, it goes dark. This is why you cannot solve a math problem in your sleep. With logic offline, the imagination network surges. Ideas, memories, and associations become untethered from waking reality. Into this active, illogical state, the brain introduces raw chaos. Deep inside the brainstem, a cluster of neurons begins firing bursts of electrical activity known as PGO waves. These electrical shock waves travel upward and slam directly into the occipital cortex at the back of your head. They force the brain to process visual data, even though your eyelids are shut and zero light enters the system. You are biologically trapped. Your logic centers are offline, your imagination is running hot, and raw electrical static is being fired into your visual software. Why would a biological organism expend the energy to paralyze its own body just to pump electrical noise into its vision centers every 90 minutes? The answer lies in the ruthless competition inside your head. The brain is highly plastic, meaning it constantly rewires its own territory. If a sense goes dark, the surrounding active brain regions will aggressively invade and consume those unused cells. For almost all of human evolutionary history, the planet's rotation guaranteed 12 hours of night. You could still hear, smell, and touch the world, but your visual system received zero input. Without incoming data to keep its borders defended, the visual cortex was in danger of being annexed by the active senses of hearing and touch during the long night. To prevent this, the brain developed a biological screensaver. According to the defensive activation theory, the visual cortex internally generates its own static to keep its cells firing, repelling the encroaching borders of the other senses. Dreaming is a mechanical defense to stop your visual software from being deleted by the dark. If the visual cortex is receiving a volley of random defensive static, why don't we see television snow? Why do we experience vivid stories instead of flashes of light? This diagram shows how your brain physically groups related concepts into clusters called semantic networks. It places related ideas in close proximity, keeping bicycle right next to motorcycle within a larger transportation neighborhood. This physical layout dictates the logic of your sleep. It explains why your bicycle can morph into a motorcycle in a dream, but it will rarely turn into a hammer, which lives in a disconnected neighborhood of the brain. As those random electrical shock waves hit the visual cortex, your brain tries to make sense of the noise. It grabs the lingering emotional temperature of your waking day, traces paths along those semantic maps, and writes a script to explain the chaotic signals it's receiving. Dreams reveal a brain addicted to storytelling, a biological organism striving to survive the dark by constructing a convincing reality out of noise.